worksheet and either model the answers or just really quickly talk you through the modelled answers that Mr. Corbett, Mr. Corbett, yeah, I don't think he's a doctor, I forget. Anyway, that Corbett Maths has done. So we'll just literally turn the pages, either going slowly with me modelling it, or faster and you just sort of skimming the answer and seeing what's going on. I think 1 or 2 I might get you to do now, but really you're going to need to practice the algebraic division skill. It takes a bit of getting used to. So I've done a whole bunch of questions on Dr. Frost for that. I think factor theorem, once you figure out what's going on, is pretty straightforward. Algebraic division needs a bit of practice. All right, I thought it's easy to get in a muddle until you've done half a dozen or so. So let's just turn the pages. So a couple of things I needed to just talk you through. First of all, I know you can't. There we go. So I just want you to for you to sort of understand factor theorem before we look at any questions. So just imagine we've just got a bog standard easy quadratic. Okay, x squared plus 5x plus 6 equals 0. We factorize it, so we've gone for the 2 magic numbers that multiply to be the 6 and the 2 magic numbers that add to be the 5, so that's plus 2 and plus 3. So that sits when it's factorized, and then from that we get the solutions, don't we? We get -2 and -3. Now, the little bit in light blue, okay, x plus 2.
Mr. Withers?
Yeah.
I don't know if I'm the only one, but I can't see anything.
Okay.
I can see it.
I can.
You have to leave and rejoin.
Yeah, I think it's. Thank you for pointing it out, George. But I think it's just you. I'm also viewing it separately.
Okay.
So don't panic. Just leave and come back in. I am recording it, so you can obviously just watch the recording once that's downloaded. And I'm also, because I'm conscious of the fact that those Teams recordings expire after about 20 days, so I'm making sure I'm putting them all on YouTube, so you got them there permanently. So sorry, George, I'm going to have to carry on without you. So our x plus 2 plus and x plus 3, they are the factors. Okay, those are the 2 brackets that multiplied together give you x squared plus 5x plus 6. So if we were asked to go and demonstrate that x plus 2 is a factor, what we need to go and do, you go and take -2, not plus 2, you take -2, you take the value of x that makes the bracket 0, you sub it into the initial equation, and x plus 2 is a factor if, when you substitute -2 back into the original formulae, when you substitute it back in, you do indeed get 0. All right, so let me just say that again. If we have a question and we need to go and see whether x plus 2 is a factor, we take -2, sub it back into the original equation, and if we get 0, then yes, indeed, it is a factor. Same with trying to decide whether it is x plus 3 a factor. We know it is, but how could we demonstrate using the factor theorem that x plus 3 is a factor? What we do, we would take -3, sub it into the equation, and just hope that we get 0 when we sub it in, and we do. -3 squared plus 5 lots of -3 plus 6 is indeed 0. So that's what factor theorem is all about. Victor.
I just wanted to ask, so like, how would you write your answer? Like, what would...
Well, we'll get on to that in a bit. I'll show you this exactly when we get onto something. I just wanted you sort of seeing factor theorem in the context of a quite straightforward quadratic that you'll be familiar with. We're going to be looking at it in a more complicated setup, but I just wanted you kind of getting it. So just with something you're familiar with, if you've got x plus 2 and x plus 3 being the brackets, how do we prove that they're factors? Well, we just sub in either -2 or -3 and we get 0. And I'll talk you through that when we get on to proper questions in a minute, Victor. Okay, now the other thing, when we get on to algebraic division, you're going to need to know how to do long division. Now, it's quite possible you've never in your lives seen it. So I'm just taking some normal division here. I'm going to do it by short division on the left, which is the one you probably know. And then I'm also going to do it by the long-winded long division on the right, because that's the method, that's the sort of the sequence we do things in when we do the algebraic division. So let's just go through the basic one on the left. And of course, it's sensible when you're doing a division like this to do it short division, because it's so much quicker. So just to remind you what you do, you go and say, how many 6s go into 7? It's 1, carry 1. And we tend to make that just a little 14. How many 6s go into 14? That's 2, remainder 2. How many 6s go into 20? That's 3 6s are 18, carry 2. How many 6s go into 27? Well, that's 6 4s are 24, carry 3. And how many 6s go into 30? That's 5. So we know the answer is 1, 2, 3, 4, 5. So now, I just want us to be able to just go through that the long division way, because that's the skill we're going to be using shortly. So what we do, we say how many 6s go into 7, and that is 1. And then what we actually do, we put the 6 underneath the 7. We do 7 take away 6, and we get 1. We then bring down the 4 to get 14. Now that's a very long-winded way of getting the 14, just like we've got over on the left-hand side. I'm just highlighting it in yellow as we speak. But that's the process that we've done. Okay, we then start again. We say how many 6s go into 14, and that's 2. Whoops, sorry, let's go back to normal pen. That's 2. Okay. And we say to ourselves, how many 6s go into 14? That's 2. But we then do 2 6s are 12. 2 times 6 is 12. We take away that 12 to get 2. And then we bring down the 0. And again, hugely long-winded. We would never really do this in normal life. Okay, whoops, sorry, I've lost my 0 for some reason. Bring down my 0. Okay, and then I just wanted to, so there we go. There's the 20 on the left-hand side, which I've just highlighted in orange. Much quicker way on the left, but that equates with the 20 on the right. And then we do the third sequence. We say how many 6s go into 20? That's 3 6s go into 20. 3 6s are 18. Then we do 20 take away 18 equals 2. And we bring down the 7 and start all over again. Very long-winded, but that 27 on the right, just doing it, highlighting it in light blue, is the same 27 is over on the left, highlighted in light blue now. Okay, and then we then just do another cycle, don't we? We say how many 6s go into 27? 6 4s are 24. So we do 27 take away 4 to give us 3, and then we bring down that 0 and say how many 6s go into 30, and that would be 5. Okay, so it would be useful for you just to do 1 or 2 of those long division. Just make up your own long division, and just do a couple of simple ones like I've just done there, long division. Because I bet you hardly any of you have ever done that method, and of course you won't have done, because why would you? You do it all in your head, and you do the short division method on the left. But that method on the right is what we're going to be doing shortly. Okay, I now want to start turning the pages of the Corbett Maths worksheet. So, and this really answers Victor's point. Okay, use factor theorem to show that x minus 1 is a factor of x3. So because I've got to show that x minus 1 is a factor, I'm going to substitute in plus 1, not minus 1, plus 1. It's whatever solution makes the bracket 0. So I'm going to substitute 1 into the function. So that's going to be 1 cubed minus 3 lots of 1 squared minus 13 lots of 1, add 15, and that does indeed equal 0. Okay, so then because f of 1 equals 0, I can then just say, therefore, those three dots means therefore, x minus 1 is a factor of x cubed minus 3x squared minus 13x plus 15. So factor theorem, if it asks you to use factor theorem, don't start launching into an algebraic division like we're going to be using in a minute. You will not get the marks, okay? And it's very long-winded. Factor theorem just requires you to take the solution that makes the bracket 0, sub it in and get 0 okay? So because it was x minus 1, we've substituted in plus 1. And because that equals 0, we can conclude that it is a factor. And it's as simple as that. So, question 2. Use factor theorem to show that x minus 3 is a factor. So what Mr. Corbett's done, he's just gone and taken 3. He's just gone and taken, oh, you can't see it yet, sorry. I'll wait for it to click through. No, you can see it now. So we've been asked to show that x minus 3 is a factor. So he's taken plus 3, he's subbed it in, he's got 0, and therefore he's included it is a factor. Question 3. Okay, now it's x plus 4 is a factor. So make sure you substitute in minus 4. Minus 4. Go and set it all out. Make sure you get 0, and therefore you can conclude it is a factor. Factor theorem is very quick. Do not confuse it with what we're going to move on to in a minute. Okay, now you can probably do this in your head. What value of x makes 2x minus 1 equal to 0? That is when x is a half. Okay, 2 lots of a half is 1, 1 take away 1 is 0. So make sure you are comfortable why Mr. Corbett has substituted in a half and not something else. You then substitute that into the function. You make sure you get 0, and therefore you can just conclude it is a factor. Question 5, again, really quickly now. What value of x makes 4x plus 1 equal to 0? It is minus a quarter. That's why he substituted in minus a quarter. He got 0 and therefore concluded it was a factor. Question 6. Okay, just the other way around. You've got to go and prove that x plus 5 is not a factor. So you go and pop in minus 5 and just make sure you don't get 0. Okay, minus 695 is not 0. Therefore, x plus 5 is not a factor. Now, question 7 part A is just like the ones we've just been doing. Okay, minus 1, show it's a factor, substitute in plus 1, you get 0, you conclude it's not a factor. Now, part B, this is the first one we're going to do together. Now, because we know it's the factor, when you take the big equation and you divide by the factor, you are going to be left with another factor, because a factor times a factor gives you the big quadratic. Okay, just remember the one I did right at the beginning when we had the x plus 2 and x plus 3. X plus 2 and x plus 3 were both factors. Okay, so if you take the big equation, so if you take that x squared, I'll go and write it at the top. So the one I did right at the beginning, if you took x squared plus 5x plus 6 and you went and divided it by x plus 2, you will go and get x plus 3. Okay, because x plus 3 times x plus 2 is x squared plus 5x plus 6. So obviously, if you've got two things being times together to equal something, if you take that right-hand side and divide by either of the brackets on the left, you're going to get the other bracket on the left. So step 1 here, we've shown that x minus 1 is a factor. Step 2, we are going to now divide by that factor. Now pay attention here, right? This is this long division stuff. You've got to say to yourself, x times what? I'll try and color code this as I go. X times what gives you x cubed. Now that is x squared. Now I want you to get in the habit of, because it's x squared, of writing the x squared above the x squared in your answer. Notice how I've got Mr. Corbett's solution over on the right, just to make sure I don't go wrong. He's gone and lined his x squared up over the x cubed. It's just a nicety, but that's not very nice. It's nicer to have it lined up like I've done it. So that's where the x squareds come from. I've then turned round, next step, instead said to myself, x squared times x does indeed give me x cubed. That's why I chose it. I've now got to do x squared times the minus 1, and that gives me minus x squared. I now have to take those away from each other. Okay, you take those away from each other. X squared take away x cubed is nothing. Minus x squared minus x squared is adding x squared, so that is also nothing. Okay, now this is quite an odd one because there is absolutely nothing there at all when we take away. This is the one occasion when we actually bring down both components all in one go. The next one we'll do, you'll just see we just do one at a time. So this is a bit of a strange one. Okay, so let's start our next lap. We've got to say to ourselves now, so this term that I'm trying to think of to put here, what times x gives me minus 4x? All right, what times x gives me minus 4x? And that's going to be minus 4. So minus 4 times x is minus 4x. The minus 4 times the minus 1 is plus 4. And when we take away, there's nothing left. So we have gone and factorized this, and we end up with our initial factor, which is x minus 1. And what we've now got on top of that algebraic division, our second bracket is x squared minus 4. Okay, so just again, I know it's getting very lots of color on it now, but just so you're clear, because x cubed minus x squared minus 4x plus 4 divided by x minus 1 equals x squared minus 4, looking at it the other way, x minus 1 multiplied by x squared minus 4 is indeed x cubed minus x squared minus 4x plus 4. And then this is, again, it's just, you've just got to then have spotted. Do you remember that difference between two squares? You've got to know, just for that final mark, and this is sort of an IGCSE top end thing, that because x squared minus 4 is a square number, take away another square number, that can be replaced by x plus 2, x minus 2. So that would be our final answer on question 7. Okay, that is fully factorizing the cubic. Now, question 8, again, I'm just going to model this. Okay, just the second bit. And then I'm going to let you loose to have a bit of a go on number 9, I think, to finish, or nearly to finish. Okay, so, well, that shouldn't have been there. So there we go. So let's just start off. Our starting point is, what times x gives us x cubed? What times x gives us x cubed? And that is x squared. So x squared times x is x cubed. X squared times minus 2 is minus 2x squared. And we're going to take away those from each other. I will change colour here. X cubed take away x cubed is nothing. Has to be, otherwise you've chosen the wrong number at the top. Now be careful here. Minus 9x squared minus 2x squared is minus 9x squared plus 2x squared, which is minus 7x squared. We then bring down the plus 20x. And we start again. Okay, we say to ourselves, what times x gives us 7x squared? Okay, and that is minus 7x. Okay, so minus 7x times x is minus 7x squared. Had to be, that one had to cancel out. And then our second claw, minus 7x times minus 2 is plus 14x. And then we take away. 20 take away 14 is 6x. 20x take away 14x is 6x. And then we bring down, what colour shall I go? Black. We then bring down the minus 12. And then finally, what times x gives us that 6x, that is plus 6. 6 times x is 6x. 6 times minus 2 is minus 12. And that leaves us with nothing when we do that takeaway. Shouldn't be anything left over because it's a factor. So we started off with x cubed minus 9x squared plus 20x minus 12. Now, having done this algebraic division, we've now got two factors. We've got x minus 2 and we've got x squared minus 7x plus 6. And then finally, you would then go and factorize that quadratic using your usual quadratic skills. What multiplied gives you 6 adds to be minus 7. So your final answer would be the x minus 2 and x minus 6, x minus 1. Now, I'm planning on us finishing with you doing number 9 in a minute. I'm just going to rattle through what other questions are here because they get easier again. We'll then come back and you can have a go at 9b and then we will finish. Okay. So 10 is more of the same. 11 is more of the same. Although part C, you are just going to be having gone and factorized a couple of things. Having gone, if you look over on the right, we've done a couple of factorizings. You then just go and cancel out as you put one over the other to give you that final answer. But 11 is more of the same. 12 is more of the same. So again, all excellent practice for you to just, not so much the part A, but the part B, where you're having to do the algebraic division. 13. Okay, now with 13, you've got to trial and error to go and work out what the first factor is. So Mr. Corbett has just guessed what happens when I substitute 1 in. So he's just guessed that. He's substituted 1 in, and he did indeed get 0. Therefore, x minus 1 is a factor. Therefore, he can then go and do the algebraic division. He will get the quadratic, and he will then factorize the quadratic. So for question 13, you weren't given that initial factor, okay? So he had to go and work out that x minus 1 was a factor by just guessing. He subbed in 1 and he got 0. If that hadn't worked, he might have subbed in minus 1 or subbed in 2. You might have to trial and error using the factor theorem to get your opening factor. Now 14, this isn't that difficult, okay? Work out the value of A once you know that x minus 5 is a factor. Well, just substitute 5 in, okay? And then in order for that to be 0, A's got to be 60. Okay, so they just haven't quite given you the whole of the quadratic. You know 5, you know x minus 5 is a factor, so you know when you sub plus 5 in, you've got to get a final answer of 0. Therefore, it's easy to work out what A is. More of the same for 14 and 15 and 16. But part B is obviously more algebraic division. 17, you were just using the fact that minus 60 was a solution to know that x plus 6 had to be a factor. Okay, so that really was just one additional little bit there. And then finally, question 18, Again, it was just another one where they gave you nothing to start. Mr. Corbett guessed, is -3 a factor? No, it wasn't. He then subbed in +3, and indeed that did equal 0. So because it equaled 0, x -3 was a factor, and then he was away. He did his algebraic division, he got a quadratic, and then he factorized that quadratic to get his final answer. So in my view, this is just practice, but it is quite fiddly, okay, until you've got used to the swing of things with algebraic division. Okay, this is a useful one to get to grips with because this is an A-level topic. Okay, those matrices we did, strangely enough, it's not in the A-level, so it's just like an extra, but this is an important part of the actual A-level. So could you all please, you can either go now, that's absolutely fine. Okay, you can either leave now, that's really the end of the teaching bit, or you can hang on and just have a go at 9B now, which I will go through in a couple of minutes' time. I'll also take any questions now, and I'll record the answers to those for any of you who are interested. So what I would suggest you do, generally speaking, just and by the way, I will upload the Corbett Maths thing I've just been working on onto Teams in a minute. So you've already got all this stuff there. If I were you, I would just go and do some of the ones that you already know the answer to. All right, because I've included all the Corbett Maths ones on the right, all his answers. So just sort of have your hand held while you do a few. And then once you're confident that you can see what's going on, just when you get an opportunity, just start doing the questions on Dr. Frost. So anyone got any questions? Please ask away now. Or you... Yes, Poppy.
It was one of the earlier slides when you were doing your original example.
Yeah.
I got confused on something.
Okay, that one or...
It was when you started putting like X's and stuff in. That might be after the orange.
Maybe it was that one. Okay, right. Okay, so what I'll do then, tell me where I've sort of color coded that quite a bit in 7B. Tell me what color bit you are happy with, or do you want me to do the whole thing again?
It was. I got the bit where it was like talk about the purple and it faded into the dark green. It was the initial X's and X cubes and stuff.
Yeah, no, fair enough. I think what would be easiest, Poppy, is if I just do part B again. Okay. So as other people, please do not feel obliged to hang on. You can either, I would suggest you get on with the question I just set you, number 9. Okay, or you might just want to leave now, have some lunch, and do it another time. That's absolutely fine. Right. Okay, let's start this one again then, Poppy. I agree. I think it's getting into the swing of it. That's the tricky bit. So we've been asked to factorize x cubed minus x squared minus 4x plus 4, and we know that x minus 1 is a factor. So your starting point, Poppy, is to focus on the x cubed and the x and say x times what gives you x cubed? You tell me.
X to an x squared.
Good. So that's the very first thing. So you've got to appreciate that's where that x squared came from. That's very much step 1. You then work back the other way. You take that x squared and say, what is x squared times x? Well, it's x cubed. But of course it was going to be x cubed. That's why you chose the x squared in the first place. But you then, sticking with that x squared, the light blue x squared, Poppy, you then multiply that by the minus 1. And that gives you minus x squared.
Okay, that makes sense.
You then take away the red bit from the green bit. X cubed take away x cubed is nothing.
Yeah.
Minus x squared minus x squared, as it happens, is also nothing. So at this point, we've just got nothing. So this is the one occasion, and it's the only occasion, where as you go into the next round of things, you don't just bring down the minus 4x, you also bring down the plus 4. Normally, 99 times out of 100, that second zero wouldn't be a zero, it would be some x squareds. In which case you would just bring down the minus 4x and you would worry about the plus 4 on your next lap.
Yeah.
Okay, so we're now going into our second lap and we're focusing in on the minus 4x and the x. And we're saying to ourselves, x times what gives us minus 4x?
4 minus 4.
Minus 4, lovely. Whoops. So minus 4, absolutely. And notice how I'm trying to get you into the good habit of the x squareds and my final answer line up with the x squareds and my minus 4's lining up with the plus 4. It's just, it's a nice nicety. The person marking it will appreciate that. Then we go, right, then we say, right, so minus 4 times x was minus 4x. And of course it was going to be, that's why we chose the minus 4. And then the second purple arrow, minus 4 times minus 1 is plus 4, which it had to be. And then as you take away, you're then left with 0. You are always going to be left with 0 because we know x minus 1 is a factor, so there should be no remainder. There is nothing left over. Okay. So we have finished our algebraic division. So we are left with our the original factor of x minus 1 and the new factor that we've just worked out, which is x squared minus 4. You then go and factorize the x squared minus 4, and that is this difference between two squares. That is x plus 2 and x minus 2. And that would be your final answer.
Yeah, okay. I think I get that now.
Yeah, it's all practice, Poppy. I remember when I did this at school many moons ago. It does take a while. You do need to practice some. So as I said, that's why I'm going to immediately give you the answers for these.
Yeah.
I'll upload them. I think you're almost going to need to copy some of these down, just sort of figuring out how it's been done. And you know, if it hasn't come naturally to you. I mean, do you want to try and do 9B together?
Why not? Yeah.
Oh, we don't have to. You can go and have some lunch if you want.
No, it's okay. We can do 9B.
Okay, let's just have a go at it. So we're just gonna set ourselves up. So we're going to have 2x cubed plus 5x squared minus 14x minus 8, and we are going to divide that by the part A factor, which is x plus 4. So what do you think we do first? What bits do we focus in on, Poppy?
The 2x cubed and the x.
Lovely, exactly right. So you say to yourself, x times what gives you 2x cubed?
2x squared.
Good, and just pop that over the x squareds because it's just a nice thing to do.
Right.
Now what?
Now it's the 4.
Well, kind of. We're going to come onto the 4. So just almost repeat that going backwards now. So you got the 2x squared by doing 2x cubed divided by x, but you now want to go the other way. So you basically say, so 2x squared times x is indeed our 2x cubed.
Yeah. And
then we focus on the 4. So what is plus 4 times 2x squared?
Is it 6x squared?
Well, 2 4s are 8, but I know what you mean.
Oh, right, sorry. Yeah.
Right. Okay. Right. You then do your taking away. So this first term must always be 0 or you've made a mistake.
Okay.
And secondly, what is 5 take away 8?
Minus 3.
Yeah, so that's going to be minus 3x squared. And that is really completing your first lap, Poppy. You've then got to bring down the minus 14x and start again.
Okay.
So what 2 bits are we going to be focusing on now?
the 3x squared with the minus bit as well. And
Exactly.
oh, ignore the banging. Got builders.
That's all right.
I don't know what.
Well, it's the
14
x still. No, it's always that. It's always going to be that x on the left. All
Okay.
right. So it's the minus 3x squared and the first term that you're dividing by. So that's always going to be the x. So x times what gives you minus 3x squared?
Minus 3x.
Good. You then repeat that claw backwards.
To make it minus 3x squared.
Exactly. And then you do your second claw.
Which is the minus 4, which makes it minus 12x.
Very good. And then you do your taking away. That first one's always going to be 0. And then you've got to be very careful. This is minus 14 minus 12.
So it's minus 26x.
No, it's not.
Oh.
Minusing a minus is a plus, Poppy. So you're doing, what we're doing here is minus 14 minus 12.
Okay.
So that overall is a plus. So that's minus 14 add 12, which is minus 2.
Okay.
So that's minus 2x. Okay, and then you get ready for your final laps. You bring down your minus 8. You do your minus 8 over. You do your
You do your minus 2x into the x machine.
Yes, sorry, I forgot to write my minus 2 up there, didn't I? That was the yeah. So I've said exactly. So I do my minus 2, exactly what you said. Minus 2 times the x is the minus 2x.
Yeah, and then.
And minus 2 times the plus 4
is minus 8.
Minus 8, which is what you're hoping, because you don't want to have anything left over when you do that final takeaway.
Like 0.
Is 0, and then so this bit of the factorising, you've got your original factor, which was x plus 4.
Yeah.
And then what you've just worked out, the 2x squared minus 3x minus 2, and then you would just have to go and do your work on the. You'd then have to fully factorise that 2x squared minus 3x minus 2. And we'll do that another day if you can't remember how to do that. That would give you your 2x plus 1 and your x minus 2.
Yeah.
And that would be your final answer.
Wait, do you do that last bit so you don't have any squares and cubes and stuff?
Yeah, you're being asked to when you factorise something, Poppy, you're just trying to get it into brackets and as many brackets as you can. You're just breaking it down as far as you can go. So okay. Absolutely right, because from that I could work out the solutions. You know, if this is equal to 0, I can straight away see that this crosses the x-axis at minus 4, minus a half, and plus 2.
Yeah. Okay.
Well done. Abs, what can I do for you?
So you know, after on the third step when we did 0 minus 3x squared.
Yes.
Say if those two were both 0, would we have to bring down both the minus 14x and both?
Yes. Okay. Yes. Just
right,
like
okay.
On question 7. So yeah, in the likely event, just so there we go. 7 should be coming through in a second, Abs. If you do end up with nothing, you do then. That's the one occasion you bring down. You've got the double arrow bringing both bits down.
Yeah. Okay.
Good question. Right, I'm going to wrap it up there, guys, because I know those of you who've got afternoon lessons, you've only got another half an hour before it starts. So I want you to have time for some lunch. So bye, everybody. I'll see you next time.